or not. All right, so I'm going to try and do it on this thing, but hopefully this will. All right, let's begin. Right. I was trying to use the tablet, but it's not being responsive. Please calm down, because some people have been complaining that when the recordings are taking place, there's a lot of background noise. So let's look at the first one. The first one says that there is a relation that contains A, B, C, D, E, F, and G. So that means there's some table that has these columns. And the first question is, what is the key for this specific table? Now what we'll do is, we can start by what? Drawing out the functional dependencies. Some people write them out in English, but I've been drawing them out. So the first one is from A, A leads to, A and B lead to C, so A to C. So A and B together lead to C. Second one is A leads to D and E, to D, and also to E. Third one is B leads to F. Right, and we also have F leads to G and H. And finally, D leads to I and J. So from D, we can get to I and J. Right. The first question is, what is the key for this relation? If you look at this carefully, any suggestions for key? Can we use just A to be a key? So A can't be a key because A alone leads to E and F. It doesn't lead to everything. Can we use B for the key? B cannot be the key because it only leads to F. But if we put together A and B, A, B leads to C, A would lead to D, E, B would give me F, F can give me G and H, and D, which was given to me by A to D, would have IJ. So my key is going to be the two things, A and B. So this will be, oh, this is not. So my key has to be the attributes that goes to everything else. Starting from just A alone can't do it. Because A alone will lead to what? Just D and E. Right? B alone can't do it because B will lead to F. But if I combine A and B, I will be able to, just from A and B, I can get to C, D, E, and F. And from then, transitively, I can get to G, H, I, and J. So that means that my key is what? A and B. What we talk about keys is we also say that they are, especially for candidate keys, we say they are minimal. A and B is minimal because if you take away one column, so if you use just A, it won't work. If you use just B, it won't work. ABC, if I said my key is ABC, can my candidate key be B? ABC. If I combine A, B, and C, can I call that a candidate key? Why? It's not minimal. If I have ABC, so the suggestion is, I can say AB is my, oh, sorry, this thing is very, very sensitive. Not the way I want it. Right. So AB is my key. But if I said I was going to combine, come on, be good. Lost him. A, B, and C. I can remove C and it will still work, right? And that means that this ABC combination is not minimal. Minimal means that you can remove one thing and what? It will fail. No, minimality, if it's minimal, that means if I remove one thing, it will fail to work anymore. AB is minimal because if I remove one of them, it's not going to work anymore. Hope you understand. So when they say minimal or when they say key, candidate key, that's what they mean. For super key, they usually don't mind about how many things are joining. But when you hear key, candidate key, often they mean the minimal one. Right. So for this one, my key is what? Just A and B. Now it's asking next that we look at second normal form. Right. So let me clean this out a bit, and then we will look at second normal form. Right. Clear. Right. So given my key is AB. That's the two things, A and B. So we are trying to get to second normal form. Right. If my key is just A and B, what am I trying to do when I'm in second normal form? What should be your goal in second normal form? You can refer to the sheets. But in the exam, there will be no sheets. So what is in second normal form? Alright, so what you have to do is, you should try and prevent people who are only dependent on part of the primary key. So what you are going to look for is looking at this one. Is there anyone who depends on part of the primary key? Right. So B to F, that is depending on just what? Part of the primary key. Also A to D and E, that's also depending on what? Part of the primary key. So those people have to be what? Taken out into separate tables.
So for the A to D and E, when you are making the tables, are you making it A, and another table A, E, or can you make it A, D?
So starting with this one, there's one guy who goes from here to D and E. But when I take out this one, realize that he's also following up with what? D leading to. So one table would have the orange, which is, I have my A, D, E, I, and J. So those will all come out. Because when A is leaving with D and E, D is leading to what? I and J. So D, I, J would join A, B, A, D, E, all to form one table. So don't leave their children behind. It's like if you're living with your father or mother, you all go together. If you depend on someone, you go along with the person. So we'll do the second. Usually you do the second before the third.
So this one, is it third or third? Because I feel like it's third. Because A leads to D.
Remember, third says that there are no transitives. Currently, there are transitive dependencies, aren't there? So I'm not at third yet. Please solve it one by one. Take it one by one. The first thing you're doing is we are in second normal form. In second normal form, we're trying to remove what? Anybody who depends only, and there's this guy who's doing the only, depends only on part of what? The key, AB. So we are taking that one out. So let's deal with one thing at a time. Second normal form before we deal with transitives. So let's not...
I think what she's trying to say is that in doing the second normal form, taking away the D and E, with what she has said, it automatically takes away, it automatically solves the third normal form as well. So when it does that, is it okay?
If you take it out and solve it, that's fine. But right now, I don't believe it will solve it. It's not going to. The tables we have will not be in third normal form when we finish. So let's go through the steps. But you can.
Leads to I and J.
A, D, E, I, and J. And D leads to I and J, yes.
So is it not a transitive? Like that's D leading to I and J. Is it not a transitive relationship?
In this table, A, D, E, I, J, it is transitive. But we are not at third normal form, so we are not taking it out yet.
I'm taking I and J out.
So please, let's try and solve this, as I said, step by step. The step is, we are taking out what? Everybody who is partially dependent on what? The primary key. So let's work with that one and then see the tables we have as a result. Let's not try and conclude right now as to whether or not it's in third or any higher normal form. When you're solving them, so you see most of the text will say, do the second, do the third. So let's see the second, what comes out, and then we'll go to the third. And when we see the second, we'll ask ourselves if we are satisfying second. So let's do one by one. I don't want to do everything and miss people. So
then from this, if we take out the AE, the DE, and we have the
oh, did I use everything? Oh. Okay, continue.
If we take out the DE and have the IJ in another table, move to that other table to go where
And go and check if that table also has a primary key and if anybody there depends on only part.
the normalize, we do that one to again.
So, yeah, so let's take one step at a time. We are going to take out A, D, E, I, and J. That's one. In here again, is there anyone else who's doing partial functional dependency? Are people saying no? I am seeing this guy here. He leads to this, and this one leads to this. So that means I'm going to have another table that's going to be B, F, G, and H. So I'm having, okay, F and G, which F and G? B, F, G, H. B to F and F to G and H. That's also going to come out. Right. And what is going to be left in A after all those? So I took out, so you're going to take out the head. So that one is out, that one is out, this is out, this is out. And for the blue group, we are not going to, you leave the root behind. Don't take out the root, don't take out B. Leave the root behind. Going to take out the heads. This guy is going, this guy is going, this guy is going. So it means that I'm going to have left just a table with what? A, B, C, another table with B, E, F, a third table with A, D, I, and J. Right. B, F, G, H, and then A, D, E, I, J. So that the root is the root with respect to the first one. So if I'm taking someone here, A, B, C, and B leads to someone, I'm going to leave the B behind. But the rest of it, so that's the root is like the top. So the root of the blue group is what? B. So I'm going to leave that in. The root of the orange group is A. I'm going to leave that in. But everyone else can be replicated in the other table. This should also be giving you an idea as to why joins happen. Why we put two tables together. Because what? Somebody has split them, but there's a common column. That's why one column is staying behind. Right? That's how, when we are joining tables, when you have many tables, they can join together. Because there's a column that was what? Left over when someone split it up. Are people understanding that point? When you have, like, we had cities and countries. In the city table, we also had, I think, the country codes in there. So that we could be able to tell that this city belongs to this country. So when you are normalizing, often some root, some column may stay behind so that what you can put the tables back together. So in this case, B is a column that will enable us. So B is the root here. So B leads to F, and F leads to G and H. And for the orange group, we have A, which leads to DE, and D leads to what? IJ. So the question she was asking about is, for this one, when we get here, we have to ask ourselves again, given the keys that we have, so A, B, C, what is the key? A, B is the key there. For B, F, G, H, the key there is what? B. For A, D, E, I, and J, the key is A. But right now, if I leave these three tables, I am in second normal form, because nobody of these three has a partial dependency on a key. Right. The translator exists because I've not done third normal form yet, but you do just step by step. So at this stage, I've removed all partial functional dependency. Nobody is depending partially on any key. And if you have a key that is just atomic, we have just one column, you are automatically in second normal form. Because if B, F, G, H, everybody there has to depend on just one value. You can't depend on partial. Right. So anytime you see any table with what? Just one value for all the candidate keys, everybody is what? Single, 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 single. It often means that what? You are in your second normal form already. So is everyone cool with this step? You are sure? Sort of. So what is left with the sort of, what is, all right, so let's go to the next stage, right? So, sorry. Oh, come on. Okay, so now I have, sorry, start with this one. A table that has A, B, and C. And the rule there was that A and B together gave you C. I had another table that was D, E, I, and J. And it was D to E, and then what? E to I and J. I also had a last one, well, the blue group. What was the starting for that one? D to. Okay, so did I mix the tables? AD. Okay, so I'm missing. Sorry. So A starts, A goes to where? D and E. And then E goes to I and J. Okay. D is the one going to I and J. Okay. All right. And what about the last one? What columns do I have there? B, F, G, and H. And for that one, B went to where? F and F. Okay, so this is my second normal form, and I want to go to third normal form.
It's like I see that it's all in one group.
Sorry, this is one table. This is another, and the last is, so not one table anymore, so three different tables. I was trying to use different colors. There are three different tables. So now I have to ask myself, in third normal form, what do I have to do? This one should be your bread and butter. Everybody's bread and butter. Right. So anybody who is non-key, you must what? And you must not depend on someone in the middle. You must directly depend on your key. So looking at this, we have A is fine. A doesn't have any issue. But if we look at this, we have somebody who is going from A to D. So if that is my key, there's this guy here, and then from that one to this and this. So it means that it will have to be what? Be removed. So this is going to have to become another table. And similarly, if you look at the BFGH group, that one as well, you have B to F, and then F to G and H. So that will have to become another table on its own. Right? So eventually, we are going to, for this one, we are going to remove what? The roots. I and J are going to have to leave the group. And for the last one, we have G and H are going to have to what? Leave the group. So let's add on those tables at long last. So I have one more table coming out, who is D, I, and J. Right? So they'll be leaving this place. And the other one is what? F, G, okay, F, G, and H. That will also be leaving. But they'll leave here, they'll leave here. Right. So now I have it in third normal form. So in third normal form, I don't have any what? Transitive functional dependencies. So try to solve it one step followed by the other. Just as I'm sure if you did accounting and you did ACCA, whatever process, usually there are certain steps you have to follow to accomplish something. You say step 1, you balance the book, step 2, forecast. There's a process to follow. And it's very scientific. So if we all did the same thing, we should have all gotten the same answer. Two people normalizing with the same functional dependency should not be getting different answers. We expect that you should all be getting more or less the same answer. I can't see how you come up with something else. Right. So is everyone cool with the 3 steps? Question? Okay, so what you have to do is, in the second normal form, you are going to be removing anybody who depends only on part of the key. So for example, last time we saw someone here, and in this case, I had a overwriting thing. So what is left with this thing? Oh wait, it's possible. I've forgotten how to do it. I should be able to write on my screen, but I've forgotten how to do it. Okay, so in this case, for example, last week we saw a country and lot were 2 things. But they were a key, and the problem was there was somebody, FD3, who was going country name to tax rate. So anytime you find your keys, anybody who is depending just on part of it, they have to be removed in the second normal form. Some people sometimes try and do second and third together, but I say just take your time, do one followed by the other, so that you are sure that you've covered all your bases. Do the second normal form, you're fine, test everything. Right? And then you get to the third normal form, then you remove the transitivities. So second is about partial dependency. The third is about transitivity. Maybe you can use T to remind yourself. T transitive. Second, partial. Right. Okay, so we are going to, this is, we just solved, it's just 15 points. This one, 15.24. So we are going to, if everyone is okay with this, we'll move on to the next question. Is everyone okay with this? Okay. So when you have multiple candidate keys, so what I was asking you to do was, if you are doing second normal form, consider everybody who could have been a primary as one of those when you are removing. So if I have 2 composites, so for example, this one, I know in the textbook sometimes, like this one, they would say, okay, and note that they even wrote candidate key, they didn't write primary key. Right? So there are 2 keys in this case. Some people are, so this is, I guess it's a struggle, a little bit of confusing issue, where you have a table with multiple candidate keys. This one has more than 1. Even though it says country and lot, there's also another one there. Property ID is also a candidate key, which has just 1 thing. Right? So it means that when you're going through this process, especially in second normal form, do consider all the candidate keys. Right? For each one, just solve it. Because what I've realized in practice is if you don't do it that way, then you still have some of the anomalies remaining. Because the anomaly that you are preventing in the first second is that anytime you have a primary key, it should lead to everything that is there. Right? But where you have someone who is only partial, that guy can be introducing a type of anomaly. So by pulling him out, so if you leave others who are dependent on other parts of other candidate keys, that issue is still remaining. So I just clear through, removing them. Right.
So does it only happen when there are 2 primary keys? Because if there's only 1 primary key, now there's 1 number of blank, now have half. So how would you know that this key depends on parts of the?
You have to write out your functional dependency.
So if there's only 1 primary key.
If there's so I think we use the terms properly. If you have a primary key that has 1 attribute, like this one, assuming that I didn't have FD2, and I just had what? FD1. That means that the table without FD2, it would already be in what? In second normal form. The second normal form, the issue from going from first to second only happens when you have a key that has what? 2 or more attributes. If that doesn't happen, then there's no need to be doing anything to the table for second normal form. So that's a good point. So if I give you a table and it has just a singular, maybe SID, and I tell you SID is the primary key, and there's no other candidate key, that because it's just 1, everybody has to depend on it immediately. So second normal form, I don't have to do anything to the table. Right. Okay, so is everyone cool? Those are good questions. All right, so let's go onwards. Right. This was an exciting one. I like questions like this. They seem very exciting because they force you to think of all the rules you've memorized. Hopefully not memorized, but actually understood. Right. So what this asked us to do was to check for certain properties, to check to see if certain functional dependencies were holding. Okay, so the first question for this was, there are many, so this is sample data. Right. And many values, and it's asking, given the current extension, so I think I told you about extension, intention, I hope you remember those two terms. Intention was the schema, extension was the data. So those are just terms that you should remember if you see anything. If someone says extension, it just means the data or the set of information. So given those, which of the following may hold? So the first one says A to B. Does A to B hold? Why not? All right. So anytime you see something where, because the whole idea for functional dependency is f of x equals y. So if you have a function, and I tell you that f of 1 is equal to 2, and later I tell you f of 1 is equal to 3, in discrete math and so on, you say that is not a function. Right? So that's the same concept that is coming on here. Right? So it means if A is leading to two different values, you can find evidence. That means that what you are violating the rule that A leads to B. So the first one does not hold. Because, and remember, usually I'll ask you why. I don't want just answers. I want you to tell me how you came about it. So why? You'd say what? Because what? In that same column, in A, 10 leads to B1, and 10 also leads to B2. You have to give me a reason. Don't just write the answer. Right. Second one is B to C. This one gets people every year. So B to C. The one there says B1 gives you C1, right? And that holds throughout. B1 always gives you C1. Next one is B2. B2 gives you C2. That's also holding, right? Okay, let's go to B3. B3 gives you C4. That's always holding. And B4 leads to C1. But that is not a problem. Because if it's a function, it's not, I think when someone says one to many, watch the direction. B4 leads to C1. There are two people who are leading to C1, but the direction is this way. From B4, I am getting a unique value. Right? So that means anytime I have a B4, I have a specific value. And anytime I have B1, I have a specific value. It doesn't matter that the values are converging. So for example, if I say student ID is the key for student, it doesn't mean that two people can have the same first name. Because what? SID leads to first name. So it doesn't really matter if two people are called Kofi, two people are called Ama, two people are called Thompson, two people may be called Jim Fee. The ID still holds. It still holds that given an SID, I am led to a specific first name. I am led to a specific last name. So please, it looks like this. The violation occurs when what? You have something like, if you had something like this, that means someone leading to two or more values. This is when the functional dependency is said to be violated, but not when they are what? Simply pointing to the same value. Different sources, same value. That is fine. And when you forget, just remind yourself that for students, SID is what? Can be the key, but multiple people have the same name. Multiple people have the same what? Date of birth. But SID is the primary key. Same concept here. So is everyone cool with this? Question? Or everyone is cool? This is a very important concept. Okay, so the second one we are saying hold, so green. Cool. Hello. Yeah. All right, so next one is C to B. Are you very sure? Okay, so what is your evidence? Okay. Oh, C to B. So C1 maps to B1. So you can see this is where violation occurs, where one person, you are leading to what? Two things. Right? It's almost like you go to the airport and one Ghanaian, you have two Ghanaian passports. I don't know, but maybe it can happen, but so far, I don't know. Usually, even if you are going to get diplomatic, you apply and they give you a new one. But I don't know, are we allowed to have two of the same? Or like one person, you have two different driver's licenses. So I have one Kojo Jimfi, one Kojo Mafu, one Kojo Osafo, one Jimfi Mafu, so multiple. If you meet me and he sees one, I give you one and then I'll keep the other one. You tell the policeman, oh, you just keep that. Okay. So please, you can have multiple of, let's say you can have a driver's license, a social security card, and so on. But I mean, they are not allowed to take your driver's license. They told you to give it to them. And he has a gun. And okay, so someone is advising that if the police ask you for, but we will have to check on this. It's in the Constitution. The number of licenses that have been seized. Okay, so let's do. So this one was also said to violate. So let's cancel this one. Right. So there's B to A. Is okay. So B1 leads to 10, and B1 also leads to 13. So that is also out. What about C to A? All right, and your evidence? C1 leads to 10, C1 leads to 13. Okay, the next question. Does this thing have a potential candidate key? Sure. So the first thing I'll tell you is this. Anytime someone says a table exists, if a table exists, it has a key. Right? Because there has to be, even if you pick then all the columns, you can uniquely identify. You can say, okay, my table, all the columns represents all the columns. So please, anytime someone says, can a candidate key exist? If it's relational, yes, there has to be a candidate key. There's no way a relational table. Okay, so that means we'll have to mine it a bit. So definitely we've been told that B leads to C. So we know that B is one of them. So B is one of the starting points. But the question is, aside from B, what else can we, so we can take out this one, because B leads to C. We know this. So the question is, between the other one, right, is there something else that we can use? But you can also see even tuple number, it's unique. 1, 2, 3, 4, 5, 6. I can use tuple number to uniquely identify you. So this is also another key. I can use tuple number, right? As a key, as a candidate key, right? It's just one singular value, and it works. But if I just pick B, I may have to combine B with something in order to. I can't use B. Can I use B alone? No, because B leads to C1 in two places. So I need someone else who is a little bit. What if I combine B and C? Will it work? Is B and C unique, the combination? No. Because B leads to C. If B is multiple, BC will not be. BC is out. Tuple number already is standing as a candidate key. If I add someone else to him, he's no more minimal. So leave him alone. He's happy. All right. So BC, I can't combine B and C. B already leads to C. And B, as we can see, B1 is repeating. B1 is here, B1 is also here. So that won't work. You can't use it. So BC, so for a candidate key, the values in there have to be unique throughout the entire database. What about BA? AB. Combine A and B. So look at AB. The first. So I didn't say just take A. I said pick A and B. So you have, let's see. There's 10 and B1. There is 10 and B2. It's not repeating. They are different pairs. 10 BA, 10 B2. They are different. Because the pairs were repeating, yes. Okay. So 11 B4 has never happened before. 12 B3 has never happened before. 13 B1 never. 14 B3. They've never happened before. That means that what? Combining A and B is also a possibility for my key. So this is another key. Hello. No, I'm saying I don't have 10B1 repeating. There's no other 10B1. That pair, there's only one 10B1. BC. But if you look at that one, there's someone like this. They are repeating. So you can combine, but what? If they are repeating, it's not going to work for a key. There are only two candidate keys. So please, the wording of people's expressions or expression of people's words or the way people are expressing things, there's something wrong about it. Say there are two candidate keys. Two candidate keys, right? One of them is composite. Composite meaning that it has two attributes being involved. The composite one is what? AB. Right? And the other one is what? Just a simple candidate key. That is just tuple number. So don't say my candidate key is AB tuple number. Make sure that your AB, one candidate, next candidate, tuple number, separate. Don't say everything together as a candidate. It's going to cause confusion. They are not the same thing. If you say AB tuple number, it's not minimal. AB, minimal. Tuple number, minimal. Separate them so that when you are speaking, you appear much more professional. You can't say ABC is a candidate key. It's not a candidate key, it is a super key. Remember we talked about the fact that there are these things called super keys, which represents, there was a video though, represents everything, but at the same time, while it's representing, it may or may not be minimal. Right? So anytime someone asks you, can I have something? And it's okay, A, B, C tuple number. The one I gave in the beginning was, if someone asks you to find a candidate key, you can never say that a candidate key doesn't exist. You can always find one. You can start with everything, but when you remove until you become minimal, you will get your candidate key. Right? So someone could have started, where's this thing? Could have started with all four. And that's what some of the computer algorithms do. Start with everything. They remove one column. They'll check to see is it unique. They remove another. And when you keep going, eventually you have what? A combination that is what? Unique. Right? So you can't say that a candidate key doesn't exist. So those who said, oh no, I don't have any candidate key. Here it's like 0 and maybe -1 for violating the rules of logic. So the candidate keys A and B is 1 and the other one is what? Tuple number. That's another one. So I have two candidate keys. One of them is composite, the AB. One of them is simple.
So when I'm talking about composite, I say
Actually, you can just say AB. AB is a candidate key. Tuple number is a candidate key.
does the position matter?
The position doesn't matter. Right. So as far as keys are concerned, please, in the relational algebra theory, positions, when you are inserting and so on, it does matter, right? That when someone is describing the data, the order matters. But when you tell me that something is a key, I know the combination is unique. So swapped in any way, it's still going to work. The order of the rows doesn't matter in relational algebra, because even if I swap the rows and shuffle them, you and I should still come to the same candidate keys. So the ordering of rows doesn't matter in relational algebra. So that was a nice problem. So is everyone cool with how we did this? We are finding unique values. So the easiest way for human beings is you can look through and say, can I find a unique column or unique pair of columns? And then you check that it's what? It's minimal. Minimal meaning that, so someone said like ABC. ABC is not a candidate key. It's not minimal because C is unnecessary. You can take it out, AB will work. So it's not minimal. Okay, so let's go to the next. All right, this was a simple one, so hopefully very fast. All right, so I've got here. So it says this relation, and there are some functional dependencies. So A, B, C, D, E, functional dependencies, A, B to C, C, D to E, D, E to B. Is A, B a candidate key? That's the first question. AB. Is AB? Someone is saying no, some people are saying yes. So, if I start from AB, AB can lead me to C. Right? From the rules above, I need C and D to get to E. So, that means I can write this as AB gives me ABC. Right? AB is implied. A implies A, B implies B. But the rule ABC will get me that AB should give me ABC. From ABC, can I get to D? No. From the rules above, I can't. I can't get to D, I can't get to E, I am stuck. So that means starting from just AB, I can only get to A, B, and C. I can't get anywhere else. So is this a candidate key? This can't work. Right. The next one is A, B, and D. Now, according to this here, A, B, D will give me A, B, D. But A, B can help me and give me also C. So C can join because of this one. Right. A, B can get me C. Right. And then C, D can get me E. And then D, E. Okay, that one is... But I have everything anyway. Right now I have everything. So that means that starting from here, sorry, AB got me C. So starting from ABD, AB got me C, and then DC got me E. So meaning that A, B, and D is what? It's a candidate. You can test the candidacy to... So you start off with what they say is your candidate key and see if what? You can reach every other column. From ABD, AB should give me what? C. The rule is there. AB gives me C. What explanation? Oh yeah, so I'm saying my explanation is starting from ABD, you have to write more actually. So I start with ABD. From ABD, I can get to what? C. And from DC, I can get to what? E. That means I'm able to get to all my attributes starting from just what? A, B, and D. That's one part. The second part, what's the second part of the explanation? So I've shown that I can lead to everything. What else is left? I've explained, but the explanation, I've only done half of it. There's something left. What else should we know about candidate keys? Aside from identifying everybody, it should be what? It should be minimal. So you should ask yourself, if I had just AB, will it work? No. The first part answered that AB leads to only C. What about B and D? would BD have worked? If I had just B and D? No, I can't do anything with BD. What about AD? Can AD get me anything? No. I have to, no, just within the ABD. So if someone says, why is ABD a candidate key? Show that what? It can lead to everything else. That's one part. The second part of a candidate key is that what? It has to be minimal. Minimal meaning, can I remove something and it should still work? And in this case, I have, so you can go through. So I have ABD. If I do AB, it won't work. If I do BD, it won't work. If I do AD, it won't work. Right, so that is now my explanation. So the explanation has two parts. Show it leads to everything. Show that it's minimal. I hope everyone is cool. Okay. The second. Okay, so let me hopefully. All right. So using the rules that have been provided for us, we're told. Sorry. We are supposed to show whether A, B, D is a key. So we are going to use the functional dependencies that have been provided. One of the functional dependencies that was provided for us was that AB should lead to what? C. So that means that from here, I can get C based on AB. Right? And also, I know that ABD should also lead to simply ABD. So I have four things. From this, ABD should also lead to what? ABD. So combining these two will get me that one. So I can combine two rules. But then, after this one as well, what about E? But the rule for E is that DE. Oh, this one is not going to work. D is not going to work. Who is going to work for me? C and D. So C and D lead to E, which is this rule. So then I can take that one and say, finally, using the rule CD gives me E. I can add on E, because CD should lead to E. So you should be able to what? Using the rules that are provided for you, systematically add on. In the textbook, you hear something like closure. This is what closure means. Closure means you start from a set of attributes and you keep expanding until you filled up everything else. It's not, I've not actually even looked at whether it's first, second, or third normal form. But the thing is, if we look at this, so she's asked a question, let's see if we can quickly normalize. Because right now you are experts at normalization, right? So if I have A, B, C, D, E, and it says AB goes to C, and CD goes to E, and the final one is DE goes to B. Is this in first normal form? Yes, it's already in first normal form. Anytime someone gives you the columns and asks you, is it in first normal form? If data hasn't been provided, you can just assume, you know what, you're going to provide me good data, I'm in first normal form. Am I in second normal form? No. Are you sure? Is there anyone? What is my key? Okay, so it says A, B, D. If that's my key, and the question is there anyone who is, it's a very messy guy. There's somebody who is depending. So I'm not in someone is depending only on part of me. So A, B, D. If you take the guy called DE to B, he's only depending on what? He's only depending on part of it. He's not depending wholly on the entire key. So you have to what? Take him out. So for second normal form, that guy who's only depending on part of him has to be taken out. So there are two people who are only depending on part of him, right? Oh, actually three people. AB, so ABD is my key. Yes. Right? ABC, okay, he's still violating because AB doesn't have D. For someone not to be, so for this to be in second normal form, everybody has to come from ABD. Anybody who doesn't come from ABD has to what? has to go and become a different table. So ABD is my key, right? So in second normal form, you're asking who depends partially on my key. B is a key. I can't say B is a key. ABD is a key. Not say, so please watch your language. Don't say ABD are keys. ABD is the key. Good. Okay. Which one? A, B to C. That rule depends only on D. He only depends on the D. Small part. He also doesn't depend. He doesn't depend on all three. If you were, so please, the only people who should remain when in second normal form is those people who can go from here and here, and also where? Here. In second normal form, the only people I'm going to allow are those people who should come from A, B, and C. Everything, so A, B, and D. Keep mixing D and C. So that means if you don't come from this directly, even if you are transitive, but you come from these three, you can also have a second normal form, someone who comes from here, because this is this, and this to another one, that's fine. But if you only do part of it, so this guy is only doing 1, 2, not 3 things. This guy is also doing 1, 2. He's also not doing 3 things. This guy is also doing 1, 2. So obviously, none of them is what? Depending on him. So they all will what? Split off into different. So this is currently not in second normal form. It's just in first normal form. If I say it's in second normal form, then I mean that I've already done the removal of the partials. I have not removed it, so I'm still in first. There's still someone here who violates second. Someone is depending on only part of the primary key. You are mixing different things. Nesting is not here at all. Okay, so that was just an additional. Let's move on to the next question. So here we're looking for key. Not fully. So when they say nested, often now what that means is someone has given you some data. And the data you are seeing that people have put certain data within other data. There's no data here, so there's no nesting. It's just like when we say multiple values in the same cell. Here, there's no such case. You have just given me the columns. So let's move on to, I think there are 2 more to go. Let's try and answer everybody. Okay, so this one is another nice one. So the car sale issue. I think most of this, well, we don't have car sales on campus. But the university, there's also a library, and then the last one is, forgotten what the last one was. Okay, so this is the car sale. So according to this, assume that, so it's a nice one. Nice questions. Oh, what happened? So you have a car sale table, right? And the car sale has car number, date sold, salesperson, commission, and discount amount. It says assume that a car may be sold by multiple salespeople, and hence car number, salesperson is what? The key, the primary key. And additionally, they've added date sold gives you the amount, and salesperson gives you the commission percentage. So we can easily do, it's my car sale. So it says that the primary key is car number and salesperson. Oh, come on. One of my functional dependencies is that date sold should lead to discount amount. Another is that salesperson leads to commission. Right. So based on the primary key, is this in first, second, third? So first, I'm not having any. Okay. Second, so there's no. One, two. There's a partial. Okay, so first we are fine. Second, what's the issue? There's a partial dependency because of what? The commission guy. But even what is my. Okay, so let me see. Salesperson is the. Oh, what about date sold? How do we get to date sold? Oh, because that has been told. Okay, good. So normally I would like to try and get everybody. So these two lead to this one. Because those, if they tell me that that is the primary key, it means everybody is what? Everybody will be led by this. The only ones that they didn't tell us about were commission number. So they gave us how we get commission number and discount amount. But for dates sold, we can assume salesperson car number because that was what was given us as the primary key. Okay, so based on this, for second normal form, there's a violation because salesperson is going to commission. And he's only coming from what? Part of the key. So for me to be in second normal form, that one has to leave. Right. So in second normal form, I'm going to have. Let me erase the top so I can use that part. It's really raining heavily today. Alright. So in second normal form, the tables I have. The first table will be car number, date sold, what else? Salesperson, and discount amounts. My handwriting is sucking. So this will be one table. This, and this will be one table. And then the other table will have what? Salesperson, and then commission percentage. So in second normal form, I'm going to get what? Two tables. Because what? I'll have to take out salesperson to commission number. It has to leave. And when it leaves, there's only going to, that means that the other table is just going to be sans this one. What is the question? Am I in second or? So I'm saying I am not in second normal form. To get second normal form, this is how I will do it. Am I in third normal form? If you are not in second, you can't even get to third. Remember, in third normal form, second normal form rules have already been taken care of. That's why I always say work in steps. Don't just say, oh, I see transit dependency, I'm moving them. You are still not in third normal form. You must clear your second normal form issues before what? You get to the third normal form. Are people cool? Alright. And for the third normal form, is there a transitive? So if I were to remove this commission thing, for the table that remains, so, sorry, let me just, it has become very nasty very quickly. Yeah, this is very, very disgusting. Alright, so I have this table, that's the second normal form. Is it in third normal form? If I have these two, date sold, discount, car number, salesperson, date sold, am I in third normal form right now? Why? Right, there's transitivity because of date sold. So date sold and discount amount have to move out. Is everyone cool? Right. So even though this looks a little, the arrangement looks different, but it's still the same. Salesperson, a car number, come to sales, date sold, and date sold leads to discount amount. So that is a transitivity. So that has to come out. Right. So if I remove that, I'll then be what? In my third normal form. So is everyone okay? Are people following? So right now, because of date sold, in first to second, I remove commission number. That came out. First to second, commission number had to leave. Salesperson, commission number to salesperson. Wait a minute. No, it was salesperson gave commission number. So commission number and salesperson will become one table. Salesperson stays. Right. Now, salesperson, date, car number, and discount are there. But salesperson and car gives date sold. And then date sold leads to discount amount. That means that I have transitivity. So for third normal form, I have to remove not date sold, discount amount has to leave. And then I make another new table. So for third normal form, the new table that's coming in is going to be, date sold, and then the discount. And that means for third, that one is leaving. At first, commission number left. At second, so at first, second, commission number. Second, third, discount amount. That will leave me with three tables. One table that has car number, date sold, salesperson, and another one with date sold, discount, salesperson, commission person. First table. So there are three tables in third normal form. Car number, date sold, person. Second table is date sold, discount. Third person, salesperson, commission percentage. So those would be my three tables at third normal form. So everyone is cool. See, this is very easy, isn't it? It's very easy. It's so easy that sometimes I don't even know why. It should be. Look how quickly we are answering this. Imagine if I was not talking, I was just writing. In an exam, we can do this in 15 minutes. It's finished. Normalization on an exam is like bonus points. It's like everybody, 3 points. Okay, let's do this one. So it says, consider the following. So the people are saying they want to make a library and so on. This is a nice little database. So a book table that has book title, author, book type, list type, author affiliation, and publisher. The author affiliation refers to the affiliation of the author. Suppose the following dependencies hold. There's book title to publisher book type. So let me take out this one so that we can start our excitement. Our happiness. Okay. So we'll move this here. These are all functional dependencies. I'll put the functional dependencies on this side. Right. It's almost like the other one. They always ask you what normal form am I in, normalize it for me. So if we draw the functional dependencies, so let's draw the functional dependencies and see. We have book type to publisher and book type. So book title should lead to, should lead to publisher and also to book type. Second one is that book type leads to list price. And then last one is author name to author affiliation. Author name. So what do I have to do first? What normal form? But even before what normal form, there's something that we always have to answer. What is my candidate key? Because without the candidate key, I can't even go to second and so on. So for this one, it looks like if I start from book title, I can get to book type and publisher. But I can never get to author affiliation. So I think that this would be my... So if I have book title, I can get to book type and publisher. From the type, I can get to list price. That means that just starting from book title, I can get I can get to three other things. But the only thing that's left with author name and author affiliation. And for that, I'll add on the second functional dependency. So author name can get me author affiliation. So is everyone cool with how I got a primary key? Okay. So now I have this key. The second question is, am I in second normal form? So from book title, I can get to where? Book type and publisher. And from book type, I can get that's part of it. The second one is from author name, I can get to author affiliation. Therefore, if I combine book title and author name, I can use that as my key. So, given my key, I'm asking, am I in second normal form? Why? And who is the partial? Right. So this is the person who is preventing my second normal form. Right. So to get to second normal form, I'll have to take out that one. Right. So let me continue. So if I'm not in second normal form, I'm not even in third. I hope that the text actually recorded that. Let me make sure it did, because if you don't do that one, you're not supposed to. This table does not, but please, if you are in third, it means that you have already done your second. So, that means I'm going to have, okay, to get to second normal form, price. So please, let's fix this right now before we go. Yeah, we can fix it right now. It doesn't. So in second normal form, book title and author name would stay. The people who will leave. So first person who will leave is author name and author affiliation. The next person who will leave is book title, publisher, and list price. Alright. And then in third normal form, what's going to happen? Okay, so T3, that table is going to be broken into people because book title was leading to publisher and book type. But book type was leading to list price. That was causing transitivity. Right. So that means I'm going to have T4, which is this, and right. So this is for third normal form. Right. So we've got them. Why are people packing up? It's past time. Okay, so I'll solve the last one and put it online. Okay.